The universe is a never-ending fractal, made up of countless, endless events known as tiny Big Bangs. If you look at a science book from before 2006, you'll see that Pluto was considered one of the 9 planets in our solar system. However, this is no longer true. About 10 years ago, the International Astronomical Union, IAU, changed Pluto's status, removing it from the list of planets. Now, the IAU is revisiting the issue because NASA has sent back clear pictures of Pluto, and it's now classified as a dwarf planet. Join us as we explore the farthest reaches of our solar system to look at the first photos of Pluto ever taken. If you're interested in staying updated on space news and its mysteries, subscribe to our channel, like the video, share it with others, and turn on notifications. We've made huge progress since the historic Apollo 11 mission, but the vastness of space still leaves many questions unanswered. NASA's ambitious James Webb Space Telescope project aims to study this great unknown. This amazing mission builds on NASA's previous work and has created excitement as we start to make groundbreaking discoveries, especially about the Big Bang and how life began in our solar system. We've made some significant advancements since the historic Apollo 11 mission, but the infinity of space presents a huge number of unanswered questions. This is where NASA's ambitious James Webb Space Telescope project intends to investigate its very own vast expanse. This astonishing mission builds on NASA's past work and has sparked great interest in interpreting remarkable discoveries from ancient times. We are naturally curious to learn more about the Big Bang and how our solar system came to have life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our solar system, revolutionizing our understanding. Although it is important to decide whether we need to look back for conclusive answers about our universe and perhaps revise them, the Pluto debate has been a subject of contention in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we now have more data to explore our local solar system. It seems that the $11 billion investment in NASA has led to an update of science textbooks to include everything we know about Pluto. This time, it is likely to regain planetary status. Here's why. Our data about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and upgraded capabilities of the James Webb that have provided the pictorial evidence needed to support our theoretical understanding of this putative planet. Although past arrangements determined which objects were considered planets and which were not, the IAU had limited solid data on which to base their decision. The criteria used for this classification might have been questioned after the decision in 2006. 2 distinct scientific viewpoints on the issue have emerged. Some believe the IAU was rushed in declaring Pluto a dwarf planet, while others quickly accepted the new non-planet status. Most spacefarers have remained skeptical regarding this issue. However, due to the fascinating discoveries of the James Webb, the question of Pluto's status remains unresolved. The sharp initial images of Pluto provided by NASA are changing how we interpret celestial history. The first and primary human encounter with Pluto was driven by the New Horizons mission, which has been ongoing for years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was when people first had the opportunity to get a close look at the space object and gathered the most complete dataset to date about its moons and surface. The New Horizons mission opened up rare opportunities for NASA in its exploration of the Kuiper Belt, a distant region of space. The primary success of the mission was the detailed exploration of Pluto, now considered a dwarf planet, and its largest moon, Charon. It also managed to capture clear pictures of 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission accumulated data, including encounters with Pluto and Charon, totaling 6.25 gigabytes. What does this data mean for NASA regarding the dwarf planet? First, the discoveries were so remarkable that researchers had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was noted that the dwarf planet was undergoing massive changes in its surface and environment. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged past beliefs about this putative planet. The New Horizons mission was crucial, and its encounter with Pluto happened nearly 9 years ago. Since then, the field of space exploration has seen dramatic upgrades through technological advances. With the addition of the James Webb Space Telescope, the possible results are becoming endless. One could indeed say that we are getting progressively closer to a total understanding of our solar system. However, there is an issue with missions like New Horizons and any efforts to explore planets farther from the Sun. The issue lies in the prioritization of resources. Spending millions to study an experimentally significant planet could raise questions about the existence of possible life elsewhere. Why venture to the edges of the local planetary system? These are pressing questions. Nonetheless, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also sparked our interest in further exploration beyond known limits. Thanks to Pluto, its study is essential in building a broader scientific understanding of other small planets. Despite its location in a cold, dark region of the universe, the first images of Pluto's surface were significant enough to reveal that Pluto is an active object in our local planetary system. As the saying goes, a picture is worth 1,000 words, and these high-resolution pictures from NASA provide us with valuable information. First, Pluto was found to have a heart-shaped feature. Most geological features on this dwarf planet are derived from its core, scientifically known as Sputnik planitia. Surprisingly, Pluto literally tilts on its heart. A brief look at NASA's high-resolution pictures revealed that this heart is a white, nearly frozen left ventricle of Sputnik's heart. It resembles a massive nitrogen glacier covering thousands of square kilometers. Another striking land feature of Pluto's surface is that the axis of its revolution has undergone significant reorientation, what scientists call a precession cycle. This was unknown to NASA before the mission. The dwarf planet's bowl is in the opposite position than expected. This reorientation has major implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the rotational axis between the moon Charon and Pluto is being affected by Sputnik planitia, the core of the dwarf planet. This impact has reoriented Pluto so that its axis is more closely aligned with its rotational axis, something that was not previously known. We have always known that this distant planet is complex for obvious reasons. However, what was not known is that Pluto's frozen surface also creates a tilt due to the irregularity in its mass. The core of the dwarf planet is a 4 kilometers thick layer of ice, which is likely contributing to its enormous mass. When combined with tides, this process can cause the reorientation of the planet's axis. However, the ice alone is not sufficient to cause a significant reorientation or to form major features. As mentioned earlier, scientifically supported studies can reshape our celestial history, and this is one such moment. Scientists have also found that Pluto is a world with its own ocean beneath its thick ice sheets and frozen surface. Pluto's interior contains a vast ocean, which also affects the reorientation of its axis. This discovery is important for several reasons, but most notably because it fundamentally changes our understanding of the planet. The highly plausible presence of an ocean beneath Pluto's frozen surface suggests that we will gain insights into its origin and how it formed. The discovery of an ocean beneath Pluto's frozen surface has raised new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to reconsider the dynamics of celestial bodies in the far reaches of our solar system. This ocean, hypothesized based on gravitational data and now strongly supported by New Horizons findings, represents a potential source of liquid water beneath a frozen exterior. Understanding Pluto's geological cycles is critical for grasping its evolution over billions of years. The dwarf planet's surface features, including its distinctive heart-shaped region and the surprising reorientation of its axis, provide intriguing clues. Sputnik planitia, the heart's left ventricle, acts as a fascinating geological feature. It is believed to be a large basin that could have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that exposed material, creating a deep depression. The New Horizons mission's encounter with Pluto in 2015 revealed a unique world, far from the cold and dormant body it was once thought to be. The mission captured detailed pictures of Pluto's diverse landscape, including mountains made of water ice, vast fields of nitrogen ice, and regions with complex patterns resembling cellular networks. These features suggest active geological processes, possibly driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, thin compared to Earth's, plays a crucial role in its surface dynamics. It mainly consists of nitrogen, with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating transient atmospheres that change with seasonal variations. Understanding these atmospheric processes helps scientists reconstruct Pluto's climatic history and its ongoing evolution. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, revealed an unexpectedly varied landscape, including a massive crater larger than the Grand Canyon and a dark region nicknamed Mordor for its distinctive shade. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history marked by impacts and geological activity. NASA's exploration of Pluto and its moons represents humanity's ongoing mission to explore and understand the vastness of our solar system. Each new discovery raises more questions about the origins, evolution, and diversity of celestial bodies, challenging existing theories and prompting researchers to develop new models and hypotheses. Beyond its scientific significance, Pluto holds cultural and symbolic value as a distant frontier that humanity has reached and explored. The pictures and data returned by New Horizons have captivated people around the world, sparking imaginations and rekindling interest in space exploration. The mission's success highlighted the importance of determination and innovation in pushing the boundaries of human knowledge. Looking forward, NASA's James Webb Space Telescope promises to further transform how we understand Pluto and other distant objects in the Kuiper Belt. Designed to launch in 2022, this state-of-the-art space observatory will peer deeper into the cosmos than ever before, using its refined instruments to study the atmospheres, compositions, and dynamics of planetary bodies like never before. The James Webb Telescope's capabilities extend beyond visible light, allowing it to detect infrared radiation emitted by objects in deep space. This ability is crucial for studying cold, faint objects like Pluto, whose weak emissions are difficult to capture with traditional telescopes. By analyzing the infrared signatures of Pluto and its moons, scientists hope to gain insights into their surface compositions, geological activity, and even potential signs of organic molecules. One of the primary goals of the James Webb Telescope is to investigate the origins of planetary systems and the conditions that led to the formation of habitable worlds like Earth. By studying objects in the Kuiper Belt, including Pluto and its neighbors, astronomers aim to unravel the mystery of how small, cold bodies came together and evolved in the early solar system. These discoveries could provide clues about the prevalence of water and organic compounds in other planetary systems throughout the universe. The technological advancements made possible by missions like New Horizons and the James Webb Telescope are clearing the way for future exploration of the outer solar system and beyond. Proposed future missions include orbiters and landers designed to study Pluto's surface more closely, collect samples, and even search for signs of microbial life in its subsurface ocean. The search for life beyond Earth is a central theme in planetary science, driving scientists to explore diverse environments and assess the potential habitability of celestial bodies. While Pluto's surface conditions are harsh and cold to known forms of life, the discovery of liquid water beneath its icy shell raises intriguing possibilities. Similar subsurface oceans could exist on other icy moons in the outer solar system, such as Europa around Jupiter and Enceladus around Saturn. Studying Pluto's subsurface ocean could provide insights into the conditions necessary for life to emerge and thrive in extreme environments. By examining the chemical composition of water and minerals in the ocean, scientists can assess its potential to support microbial life or preserve evidence of past biological activity. Future missions, equipped with advanced robotic technology, could drill through the ice to access the ocean and search for signs of life. The exploration of Pluto and its moon system also contributes to our understanding of planetary defense against potential asteroid impactors. Objects in the Kuiper Belt, including Pluto, are remnants of the early solar system and can offer valuable insights into the frequency and nature of impacts that shaped planetary development. By studying impact craters and surface features on Pluto and its moons, Experts can reconstruct the history of cosmic collisions and assess the risks posed by near objects. NASA's planetary defense efforts aim to detect and track potentially hazardous asteroids and comets that could pose a threat to Earth. By studying the characteristics of the Kuiper Belt and other regions of the solar system, astronomers can improve their ability to predict and mitigate impact risks. Future missions to Pluto and other Kuiper Belt objects will contribute to these efforts by expanding our knowledge of celestial dynamics and the geological processes that shape planetary surfaces. In addition to scientific research, the exploration of Pluto evokes wonder and curiosity about the universe. The images and data returned by space missions capture the imagination of people worldwide, fostering a sense of awe and appreciation for the beauty and complexity of our solar system. As humanity continues to explore and expand its understanding of the universe, each new discovery brings us closer to uncovering the mysteries of our astronomical origins and our place in the cosmos. The exploration of Pluto and its moons embodies the collaborative nature of space exploration, with scientists, engineers, and researchers from around the world working together to achieve ambitious goals. International organizations and partnerships enhance our ability to conduct complex missions, share data, and advance scientific understanding for the benefit of all humankind. By pooling resources and expertise, space agencies can tackle challenges that would be difficult for any single country or organization to address. Looking ahead, future generations of scientists and explorers will build upon the foundation laid by missions like New Horizons and the James Webb Telescope. Advances in technology, including artificial intelligence and autonomous robotics, will enable more sophisticated missions to explore distant worlds and unravel the secrets of the universe. These missions will continue to push the boundaries of human knowledge and inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM. In conclusion, the exploration of Pluto has revealed a dynamic and complex world far beyond our previous understanding. From its diverse surface features and subsurface ocean to its unique atmosphere and system of moons, Pluto challenges scientists to reconsider planetary processes and explore the potential for life beyond Earth. Future missions, driven by advances in technology and global collaboration, will continue to expand our knowledge of the universe and deepen our appreciation for the wonders of space.